All right, so lesson 19. Which one changes faster? So the goal is to compare linear and exponential functions as they continue to increase. Because as you'll see on your test, including the constructed response, it's gonna have you basically see which one is worth more after X amount of time. So here's your warm-up. There's the graph. Which equation do you think the graph represents? So we'll take a poll. Raise your hand if you think the first equation is best represented by the graph. Three people. Raise your hand if you think the second equation is best represented by the graph. Okay, about 6 people is what I counted. I can tell you the 3 people that chose the top one are correct. Why, you might ask? When a graph is a straight line, what type of function is that? Linear. What equation do linear functions look like? Good. Glad we have more people noticing that from we just went over it in the study guide. So we have multiplication and adding. This one has adding and multiplication, so that's fine. We would still do multiplication first per the order of operations. What type of equation does the bottom one look most like? The exponential, because that one would be what formula? Close. There's more in there. Good. And that B is the 1 plus or minus R. So good. What information might help you decide more easily whether the graph represents a linear or an exponential function? All right, that sounds kind of like a opinion type question to me, but you could also look at it in tables, like in those patterns, like for an arithmetic sequence, those are like your linear type functions. That would be like adding the same amount each time. So if my outputs look something like this, that would also tell me that it's linear. Maybe the other part of my table looks something like this. All right, for exponentials, it might look like this. So still the x's might be 0, 1, 2, 3 going up by 1. But if it was multiplying each time, that would be clear to see, like for example, something like that. Like you could think that it's adding 20, but then once you compare it to the next 2 numbers, it's clearly not. So then you try and see if there's other patterns going on, see if there's a common ratio. Common ratio is associated with your exponentials. All right, I don't know 125 times 5 off the top of my head, but that's what would continue the pattern. So questions on the warm-up? All right. So then a family has $1,000 to invest and is considering 2 options. Investing in government bonds that offer 2% simple interest, or investing in a savings account at a bank which charges a $20 fee to open an account and pays 2% compound interest. Whenever it talks about different interest, by the way, and you don't know what it's talking about, try like a Google search. I'm not gonna lie to you. It'll tell you. These are really common phrases that people use. So simple interest versus compound interest. I know that compound interest means that it applies to like your balance. So including your starting amount and any interest you already have. Anyway, it says both options pay interest annually. What does annually mean? Yearly. And someone asked about some phrases on their homework. What does semi-annually mean? It's 2 times a year. So semi-annual means 2 times a year, so every 6 months. That's why when stores have semi-annual sales, if they're like 6 months away from their annual sale. And I'm sure there's other phrases like one said quarterly, like they compound interest quarterly. What does that mean? 4 times a year. All right, so divide 12 by 4, that's every 3 months. So yeah, just FYI, that's not necessarily all in this problem, but I've been getting some questions. All of which you can Google. So here are 2 tables showing what they would earn in the first couple of years if they do not invest additional amounts or withdraw any money. So how does the investment grow with simple interest? So let's make sure we know what simple interest means. Anyone know what simple interest means? Okay, I could guess, like I think I know, but I'm not gonna assume because we know what assuming does. But simple interest is a charge on borrowing that's calculated using an original principal amount only and an interest rate that never changes. So it's not like timesing 1.08 every time or something like that. It's timesing it just to the original principal amount. So like we're adding the same amount each time because that would never change. Does that make sense? Okay, so then back to the problem. So how does the investment grow with simple interest? Try that on both accounts. So yeah, play around with it, see how it grows with the simple interest, which is the one on the left. Versus the compound interest, which is the one on the right. So just look at it. Also try to continue the table as well. So I'll give you like a minute to do that. All right, so table 2, the one with simple interest, would you say that it grows linearly or exponentially? Good. So this one is more linear. What does it look like they're adding each time? $20. So looking at the outputs, and if you check back to what they said originally, they said that the bond offers 2% simple interest. So 2% of $1,000 is $20. So they're not applying the interest to what they have currently, just what was originally put in there. So at year 3, what would the investment amount be, table 3? 1,060. Good. Table 4, what would the investment balance be? Good. All right, so find the pattern, continue it. If it's adding each time, it's linear / arithmetic. Table 5. How would you describe the one with compound interest, linear or exponential? Exponential. Class, does it look like this is adding each time the same amount? No. And we also talked about how compound interest charges you interest on like the total amount that's there. So when we look at that, what it said for the savings account, that charges a $20 fee to open. So minus 20 from the 1,000. That's how they got 980 initially. And pays a 2% compound interest on whatever the balance is. So that's why you can use this that we've been doing to figure out what you get next. So what are they multiplying by each time? What's my B going to be? 1.02 is correct. All right, because it's growing, so it should be bigger than 1, because it's the 1 plus or minus r, so growing is bigger than 1, and the rate is as a decimal, so 2% as a decimal is 0.02. Good question? All right, and then if I double check that on my calculator, I'll just do it on my own calculator. I won't necessarily put it on the screen. But $980 times 1.02 is $999.60. And you take that amount times it by 1.02, you do get $1,019.59. So then table 6, in year 3, what would we have? All right, if you got something different, make sure you're taking the previous number, multiplying it by 1.02. Table 7, what would it be in year 4? Good, so that's $1,060.78 for this one. Good, question? All right, so that's how you can tell from a table. So we can tell from a graph. By the way, I just looked at this in the book and it said that you could make arguments for either one, either it being linear and either it being exponential, which I can see now because exponential functions start like around the same, and then they either increase really fast or they decrease really fast. So I can see why it could be both, but really, like, if you're looking at the formula, it should be in either of these forms that you can tell. All right, but good. Just a little bit more and then we'll wrap up. Let's do the one with function notation. So we kind of answered that by filling in the table. So let's look at this part with the function notation, because I think we need more practice with that. So to complete the table, what am I doing to complete the table? Like for the f of x column. If I want to find what f of x is and my x is 1, what do I do with that one? Plug it in for x in the equations. So if I want to find when f is 1, plug it into the equation. Anytime there's an x, replace it with 1. Also, anytime you plug things in, use parentheses. So then what's 2 times 1? 2. So that's what my f of x is. If I want to figure out what g of x is, what's my x in this row? 1. So then you're plugging in 1 now into the g of x function. So now it's 1.01 to the first power, which is just 1.01. You can check it with the calculator if you want. So just fill it out. For up to 500, I think it's fine. So plug in these x's. You should see that even though this one starts out bigger, the exponential function will eventually like grow at a faster rate, right? So f of x is linear. If you didn't notice, it's y equals mx plus b, so it's multiplication. This one here is exponential, so y equals a times b to the x. So just fill that out. Once we do that and we go over it, then I'll give you time to work on whatever you need to work on, because Monday is the deadline for the paper. So this is my table filled out using a calculator. So first one, I didn't really need a calculator because it was just 2 times whatever x is. So 2 times 10 is 20. 2 times 50 is 100. 2 times 100 is 200. 2 times 500 is 1,000. For the exponential example, where I had to use a calculator, so make sure that you guys do the same. We're replacing the x in the exponent spot. That's what makes it exponential. So then to the second power, or not to the second, to the 10th power, that's what I got, but I rounded it 2 decimal spots. It didn't specify. To the 50th, looks like that. Rounded it 2 decimal spots. At the 100th power, it is that. And then at the 500th power, it is that. So it looks like that this one is growing at a slower rate just from actually doing the numbers. But given enough time, it will eventually surpass this one. But as to whether or not it'll reach a value of 2,000 first, what do you think? Which one do you think will reach it first? You think the f of x will? All right, so a few ways you could figure that out. You could keep playing with numbers and see which one actually reaches 2,000 first. You can make equations and figure that out, plug it in. You could also graph them. So y equals 2x. I could also put f of x, but I'll just leave it as y. And y equals 1.01 to the x. All right, so we can see our 2 lines. It looks like the blue one is higher, the linear one is higher for a really long time. But eventually, this one will exceed it on the y. All right, this one eventually becomes higher. Now to see which one reaches 2,000 first, well, here's the 2,000 line. Which one reaches it first, the exponential or the linear? The exponential. So it looks like it reaches it at around an x of a little before 800, whereas this one needs an x of 1,000 to reach it. So either way, I suggest doing the math or graphing it and seeing for sure. So good. Questions, comments, concerns? All right, so that's really it. You have like 9 minutes remaining. You could work on your study guides. You could ask me more questions. Definitely that. Study guide should be your first priority. You don't have a puzzle piece for lesson 19. Just the little activities we did in class today is fine.